Hi, good morning. Again, I'm Zach Metzinger in 0ZGO. I'll be your MC for today. And first up, we have a presentation by the VP of Educational Resources, Alan Johnson here. And he is going to talk to us about CubeSatSim update and demonstration. So off to you, Alan.
Okay, thanks, Zach. So can everybody hear me okay? It sounds good. Okay, all right, excellent. So good morning, everybody. It's a pleasure to be back here in Dallas. I used to come to Dallas a lot. Years and years ago, I worked for WorldCom before they merged with MCI. And so I used to spend a lot of time in Richardson in the telecom corridor there. So anyway, it's good to be back. So today I'm going to give you an update on some things that have been going on with AMSAT in our education program, and specifically about our CubeSat simulator that I have some of them here. And I'll show off some of the new features, including a live demo, which I'm sure will fail. But let's give it a try here, see how we go. So I'm going to start off by mentioning the team that's been working on this, because I stand up here and give presentations, but there's a whole lot of people working on this, and without them, we wouldn't be where we are today. We'll introduce the CubeSat simulator. How many of you have not heard me speak about this before? I see some. Okay, good, excellent. All right, very good. Some of you might have heard me at Hamvention or other symposiums as well. So we'll talk a bit about what we use it for, what its purpose is, and then we'll talk about basically what we've done with it in the past 12 months. So we'll talk about it in the classroom, at events, articles that have been written about it by my team and others. Then we'll do a demo here, and then give you information about how to get involved in the project. So this is the team. All these different people have been involved. So thank you. Anyone here in the audience on the team? I don't believe so. Oh, Chris, where's Chris? There you are, Chris. Okay. Thank you, Chris. Chris has supported us with changes to Fox to LAM, basically spacecraft for the CubeSat simulator for that. So thank you, Chris. So what is a CubeSat simulator, or CubeSatSim, as we call it for short? It's the sort of centerpiece of our educational outreach. And the idea is that, satellites are cool, but they're way up there in space, and you can't see them, and they only fly over, for 10 minutes twice a day. And so that makes them a little bit hard when you're trying to explain to students or do demonstrations. So having something that you can have in your hand and you can pass around. Also, it's designed to be low cost, so that if a student drops it and it smashes, it's no big deal. We wouldn't normally pass around flight hardware that's going to be shipped to the integrator next month. So it's a good way to do the hands-on. And so we use it in schools. It's used in a number of universities and STEM programs. And we're also trying to get it into sort of non-conventional places like maker fairs, libraries, museums, and things like that, just so people know, ham radio is still there, and we're doing cool, interesting things with space. So the CubeSat simulator, it's basically a fully functional model of a nanosatellite, a CubeSat, the standard for nanosatellites these days. And you're going to hear from Bob Twiggs, who's one of the co-inventors of the CubeSat standard at this event. I'm excited to meet him in person. And it's basically fully functional. It runs on rechargeable batteries. It's got working solar panels. It transmits real radio signals in the 70 centimeter band. And it transmits them in real format. So you use the same software you would use to receive telemetry and decode telemetry and receive images is what you use with the CubeSat simulator. So you can also treat it like a trainer, basically. You can train and get all your software working, and then just switch to an outside antenna, and you can receive telemetry and images from real satellites as they fly over. So this is what it looks like inside, and I have it here. It's a 3-board stack. It includes a Raspberry Pi Pico microcontroller, It also includes a Raspberry Pi Zero as well. And it has a number of sensors too, and I'll talk about some of those. And this slide here shows the excellent FoxTeLem software, which is what AMSAT uses for our CubeSats that are on orbit. And many of you might run FoxTeLem in your station, and you might upload the telemetry data you get into AMSAT servers so that AMSAT engineering can see what's going on with our CubeSats. So this is one way that we get telemetry out of the CubeSat simulator. You can look at voltages and currents and temperatures and things like that and see them happen in real time. So the CubeSat simulator has been around for a few years. I've been working on it myself for a couple of years, and we have a version, the current version is version 1.2, and quite a few of those have been built. We're working on a new beta, bless you, a new beta hardware and software, and we've been working on it for the past 18 months. It's been a little tricky. Part of it was motivated by supply chain issues. It's very difficult. You know, the CubeSat simulator is basically a kit. We don't currently sell fully assembled units, so we provide a bill of materials, and keeping that bill of materials up to date so that people can actually buy the parts on there is just, frankly, it's just been a nightmare the past year and a half. It's so difficult. And so anyway, so we've tried to redesign to make the parts easier to find, and also make the bill of materials a little easier as well. And also updating some of the technology like the Raspberry Pi Pico microcontroller. And along the way, we've also added a couple of features, but it's not a big upgrade. It's really just sort of future-proofing the hardware, basically. And you can tell the difference between the two. On the left there, the whiteboards, that's the current version. That's the released production version, version 1.2. Our new boards, we're going with this cool blue. So that way I'll always be able to tell, so I won't be confused when my first question for support is going to be, what color are your boards? Because that will tell me right away what's going on. So I'll just go through a couple of changes because some of you might be familiar. I think some of you have definitely built CubeSat simulators. I know Chris did and Dennis did. Anyone else in the audience build one before? Oh, okay, excellent. Oh, terrific. Wow. Okay, very good. So you'll be pleased to know that there's actually a path to upgrade your existing CubeSat simulator. You won't get all the features of the new hardware, but you will get many of them. Basically, you can build a new STEM payload board and then replace your existing STEM payload board, which is the top board on the stack, with this new one, and you'll get many of the features. And what are those features? So we replaced the SparkFun Pro Micro microcontroller with the Raspberry Pi Pico. Anybody used a Pico before? Played with that? It's kind of cool. It's really nice to program. You just drag a UFT file on into a flash drive, and it just programs the whole thing. It's great. You can also program it in Python, which you know students in schools really like Python much more than C. I don't know why. I don't know why, but anyway, it's quite popular. So that's something good for the future. Also, it has Wi-Fi. It's the Pico W. So in the future, we're going to do things with Wi-Fi as well with it. Also, it has this little board chip thing here. This is a FM transceiver module on there. We had some issues with FM on the original board with frequency offsets, and also we had issues where as soon as we put this thing out there, people immediately started to misuse it, which is always good, right? That means they're experimenting. And the one thing that kept coming up is, can we fly this on a balloon? Well, first was, can we send this to space? And it's like, no, don't do that. Okay, this is designed to be ultra low cost and easy to build, and you know it's not designed to survive in space. But the second, not quite as unreasonable, was, can we fly it as a payload on a balloon? And so some of us tried it. I tried it twice. And it wasn't a good experience. The power level was too low. There were frequency offsets that caused issues. So like your APRS beacon would be off by 5 kilohertz, and all the digipeaters wouldn't receive it. Oops. things like that. So now we have an FM transceiver board on there. And for the simulator, we just we attenuate it down to 10 milliwatts. Because generally our ground station, like my ground station is that Pi 4 over there, we don't want to blow it up with our transmitter sitting right next to it. So we really attenuate it. But if you remove the attenuator circuit, you can get a half a watt, 500 milliwatts out of this. And we successfully flew that on one of our balloons back in May. We did slow scan TV and APRS live in flight. And it worked really well. So in the future, the answer is going to be yes, you can fly it as a balloon payload. Some of the other details. Oh, there is a new frame. So if any of you have printed the old frame before, we do have a slight update. The frame is 3D printed plastic, which students like to. It's a lot of fun printing it, watching it come in. We have a better bill of materials now. I'll show you that while we're doing some demos here. And also, there is a surface mount assembly option. How many of you have done surface mount soldering before? Oh, okay, lots of you. How many of you like surface mount soldering? Not me. Okay. It's good if you have good eyesight and a steady hand, which is good for youngsters. Some of my students, you give them the thing, and it's done in like 2 minutes. They're really quick at it. So my students actually this past spring did a surface mount assembly, and it worked well. Ran it through the reflow oven, and that was good. But also we're going to use that next year, hopefully, to make fully assembled boards. So we'll be able to make, we'll still call it a kit because you'll have to stack the boards yourself and put it all together. But it'll basically be a no soldering kit. And I think that's going to be a good thing for the future. Because right now, when people are like, oh, I want one, here's a check, and we're like, okay, here's a board and here's a bill of materials. That might be good for us, right? But it's not necessarily good for the average STEM outreach person. So. Okay. So a little bit of details on the board, and then we'll get into some other things. So this is the STEM payload board, which is the one that I'm holding here. And besides the Pico, it's also got 2 sensors. It's got this purple BME 280, which is a pressure, altitude, temperature, what's the final thing? Pressure, humidity sensor, which is fun because you can make it do things. You can put it outside and see the temperature change. And it's also got a 3-axis gyro and accelerometer there, which is fun. This is what we call the solar board. What it really is, it provides all the circuitry to run the solar panels. So it's got diodes to prevent backfeeding, and it's got these blue boards here are INA 219 boards, actually made by Texas Instruments. They're really nice little chip, and it gives us current and voltage sensors for every solar panel and the battery, so we can look at this in real time, which is fun. And one of the fun things that we do, I don't have the demo here, but we use a little turntable like for spinning cakes or objects or things. And if you put it in front of a lamp or if you just put it in sunlight, as it spins around, you can see the currents and voltages spike on the solar panels. And that's exactly the kind of telemetry you get from real CubeSats, right? Because they're always spinning in space, and one side faces the sun, and so you can determine, axis of rotation and rotation rate and things like that, which is fun. And one of the things in our new design is we're using these smaller solar panels, so we're using 2 on each side, and these solar panels are easier to source. Before you had to locate them on AliExpress or eBay, places like that, unless you wanted to pay an arm and a leg, which for me is like $10 a solar panel. These are about $1.50 each, which is what we need to keep the costs down here. So I have a battery board. One of the most common questions I get is, why do you use nickel metal hydride batteries? Why don't you use lithium, right? They're much more powerful. Well, some of my, actually I didn't have anything this semester. Previous semester, students were soldering the board with the batteries in, and they bridged the positive and negative with solder. Okay? Now imagine that with lithium batteries. Okay, you'd be calling the fire department, you'd be explaining to the dean what happened to the lab. With this, all that happened was the trace glowed red like a toaster. Something to see. And fortunately, I was standing right there, and so I just grabbed the soldering iron and I unbridged it. And those batteries actually kept working. So nickel metal hydride batteries, they're very, very safe for students to work with. It's very hard to do anything to destroy them or to destroy your lab or your hands or something like that too. So anyway, so nickel metal hydride, not the latest battery technology, but they're cheap and they're very, very safe. And they also allow us to have a very simple charging circuit. In the past, we had a charging circuit that used a chip, and I've been concerned about those boards becoming unavailable in the future. So now we actually just charge it directly because nickel metal hydride batteries, they're really tolerant to what you do to them. So that's allowed us to simplify things, reduce costs. And you can charge them using the solar panels in sunlight. Indoors, you'll never get enough current out of the solar panels unless you use, in the past I've done demos with like work lights. You know, there's like 250 watt halogen work lights. Those you can get power out of a solar panel. You also need to not melt the frame. So you need to keep it spinning if you're going to use those. And don't let anybody touch the grill because they're hot. But if you just put put an LED light, which is cold and safe, in front of it, you can see a little voltage spike and a little current spike. But if you really want to charge it, you need sunlight or you need a high power warm lamp like halogen. And in addition, you can charge it from a USB-C cable. So generally that's what I do. I just charge it overnight before I do a demo like today, and then it's good to operate for a while. So there's a couple options for the ground station. As I said, it generates real telemetry. So you can, for example, use an SDR application and decode it, and then you can run whatever software you might run, whether it's Direwolf or QSSTV or MMSSTV on Windows, Sound Modem. You know, if you decode satellite telemetry, you might already have the software there. If not, you can install it. An easier solution is to do basically a ground station in a box where you can load up, we have all the software pre-installed on a Raspberry Pi SD card. So this is it over here. Basically, it's just a Pi 4. A Pi 3B Plus works. It's a little bit iffy for everything, but a Pi 4 is good. And then an RTL SDR, which is our radio piece of it. And you don't need much of an antenna. I always like showing my students how a paperclip works as an antenna. It kind of freaks them out. They're like, really? That works? Sure. It's a conductor. And the nice thing is that if you just put this SD card and boot up the Pi, it turns on like a radio, and it's got all the software you need, and you just switch. I'll be showing it a little later. So these are the 5 different modes. We'll hear most of the modes today during my demo, if all goes well, which I'm sure it won't. So a little bit about the telemetry. So I'm an electrical engineer myself, and telemetry is an interesting thing. And basically, the CubeSat simulator sends what we call housekeeping telemetry. So just the basic health of the satellite itself. So temperature, voltages, currents, the battery, what's going on with charging, what's going on with battery draw. You can tell a lot about the health of a satellite looking at the housekeeping telemetry. And then in addition, if you add sensors, and with the STEM payload board, you mix in additional information as well. So those are like your experiments. Those are like your payloads that your CubeSat is taking. And the nice thing is that you can program those using, basically using the Arduino IDE development system. So we use the Raspberry Pi Pico, but you can just program it using the Arduino IDE. So it's very simple for adding new sensors. And we've also just added, I don't know if you can see, but there's this little red board here. So it's a SparkFun Quick connector. So if you buy I2C sensors, a lot of them will have this quick connector on them, and you can basically wire them up without soldering. So you just have a little quick jumper cable, you plug it in here, you plug it into your sensor, and then you just need to update the software on your Pico, and you've added a new sensor to it. So that's kind of exciting. And in addition to the real telemetry that the CubeSat simulator will do, it also has the ability to generate simulated telemetry as well. It's a mode you put it into. And it generates, pseudo-realistic things with it basically calculates a rotation rate and an angle of rotation, and whether it's in eclipse or illumination, and chooses a period. It actually chooses a very short orbital period. You don't want a real orbital period. It's like 5 minutes kind of thing for the attention span. And then you run it, and it will generate, pseudo-realistic telemetry, which is good for doing demos and the like. Because not everywhere can you set it up with a turntable and a lamp and all that. And each time, all the parameters are randomly chosen. So every time you reboot it, it'll be different. And when it comes up, you don't know, is it an illumination? Is it an eclipse? Is the battery discharging? Is it charging? And so you can look at the telemetry and do it. So it's kind of fun. Okay, so I'll talk a little bit about what we've done with the CubeSat simulator the past 12 months. Things got pretty slow in education during the COVID time, as you could imagine, but things are ramping up. And actually right now, well, I just got one of them back, but I had 4 of our loaner units were shipped out. And this was the first time in a couple of years that 4 of them were out at the same time. Recently, they've only been borrowed every couple of months kind of thing. But we have been using them in the classroom at the Thomas Jefferson High School for Science and Technology in Alexandria. They actually built quite a few of them and used them in the classroom. They've been used at the University of Colorado Springs in some aerospace engineering classes. They developed some labs with them where students had to answer questions and do things with them. And I myself, I've used them in this past spring in my freshman projects class. So this is like the first electrical engineering class that they do. And we don't really teach them a whole bunch. We just kind of want to get their feet wet. And so we give them the instructions, we give them a pile of parts, we give them a soldering iron, teach them which is the hot end and which is the cold end. And then we say, go for it. So, and the kids actually enjoy it. One of the fun things is when they contact me like a year or 2 later and they're like, what did we do in that class again? Did we build a satellite and put it into space? They have this vague recollection of what they did, and then they're like, did we actually build a satellite? I'm like, oh, almost. But anyway, it's a good class. And building, for those of you who have built them, building a CubeSat simulator, it's pretty fun. It's about 10 hours of soldering and 3D printing and other things. So at events, the CubeSat simulator's been at a few things. Dennis here took it to Hamcation. Thank you, Dennis, for doing that. And I participated in the QSO Today Academy twice this year. I showed it off there with their online event. And we also had it at Hamvention, and again, Dennis helped staff the table, along with Karsten Glassbrenner. Drew's son, who did an awesome job. He was, we have our, this is our Fox engineering model here. That's always a big hit at Hamvention, and he was putting it in the hands of every kid that walked by, and he just did a great job. Okay, good. And he's hopefully going to be building one too. So maybe next year he'll say, "I built this one." We'll see. Oh yes, yeah, and then Tom in the back there. Thank you, Tom. He's taken it to a event here, Frontiers of Flight Moon Day. Looks like a great event. I've seen the pictures. The latest pictures, if you go to the pictures and the overall picture, you can see a banner in there, and it says "Keep Amateur Radio in Space." So, yeah. Yes. Excellent. Excellent. Yeah, he's saying that Virginia Smith built one and showed it off to a local Dallas ham club here. Yeah, I was hoping to meet her on this trip. Last year she also wrote an article in the AMSAT Journal about her experience, and she's recorded videos. Yeah, she's a great resource for this. Okay, excellent. Yeah, exactly. The purple creatures. Yeah. Okay. Very good. Yeah. No, it's a lot of fun, and you know, kids can do it. I don't recommend it as a first soldering project, right? But like a second soldering project, or maybe you solder the pin headers and things because you don't want every one of them bridged. So we've also had, the CubeSatSim has also been in the AMSAT Journal a bunch of times. There was a great article just recently, July, August, by Olivia Bellion. She was an intern at the Savannah River Federal Research Lab. And she basically built, I guess she 3D printed the CubeSatSim frame, and then she decided she could do better, and so she redesigned it, which was really cool. And she wrote an article about it. So that was her intern project, which was great. There was also a good article by Paul Graveline. Paul? There's Paul. Good to meet you, Paul. Paul and I we've been working together on this project for almost over a year now. So all right, good. I need to stop by and say hi. So Paul wrote this article where he interviewed Bruce about his experience building it. So it's a good neutral article, not by a biased person like me who will say it's a lot of fun. And then I also wrote an article about some of the hardware changes that are there. There was a segment, I guess, of celebrating the 20th anniversary of the CubeSat standard, and it was on the NPR Science Friday, which is their national program. And a teacher, Darren Yu, out in California, he's built CubeSatSims in his classroom, and so he mentions it in his interview, which is nice. Also, AMSAT UK recently built a CubeSatSim, and this image here is from their colloquium, which was just last weekend. I actually watched it live, and Dave Johnson there, G4DPZ, he actually demoed it. He did a live demo, and it even worked. So that was good. That was showing it off to the UK audience there. Also, in the UK, they're now stocking the blank boards on their store, and they ship to the rest of the world. Because here on the AMSAT store, we only ship to US addresses, but now the UK, AMSAT UK is supplying the rest of the world, which is great. And I mentioned that we did a balloon flight back in May, and we flew an earlier beta version of this CubeSatSim hardware, and it worked quite well. Okay, are we ready to do a demo here? Enough of me talking? Okay, so I'll turn on my radio here. So we're going to be transmitting at 434.9. If you have a radio, you can turn it on if you want. So we're going to launch it just like we launch real satellites by taking out the remove before flight. And if we do that, we will get going. So one of the things you'll notice with the, I should show see if we're still, okay, we disconnected. We'll need to reconnect the ground station. Let me just do that. So I'm using VNC to log in. If you want to. No, actually, I'll need to push buttons and things. So, okay. Default password Raspberry. Okay, so this is our ground station, which is also basically the Fox in a Box software that Burns and Chris put together here. So let's see, I'm going to start running the WebSDR here. And so we see the green light is on, indicating the software is running. The blue just flashed, indicating that the transmitter is getting ready to go. And in a minute, we should hear something. There we go. Okay. Anybody copy the call sign? Yeah, that's a familiar one, right? That's AMSAT's call sign. Okay, so this is a, oh, there we go. Here the APRS packet. It's starting up in mode 1. So this is it's known as a web SDR. It's basically an SDR interface, but you access it through a web browser. So it doesn't have a million controls. Right? 'Cause I really hate when you run an SDR software, when you start it up, nothing happens. Right? You got to find the magic places to press, and then noise comes out of it. And that can take you, hours, days, who knows how long, till you actually get the thing to do what it's supposed to do. This just comes on, which I like. And it's got built-in decoding. So if I click here, this actually fires up an APRS decoder, and so it should decode these packets as they come in. So we'll see if that works. And one thing to notice the CubeSatSim now has 2 antennas, and that's because we actually have two transmitters in it. And one of the transmitters is also a transceiver. And so for the first time, we're able to actually receive radio. And so one of the things I'm going to demo here, there we go, that worked. See the packet here? So W3ZM-11. So I actually have it in high altitude balloon mode, in HAB mode right now. So it just says hi, hi, and then it gives the battery voltage, 3.96 volts, the battery current, which is 397 milliamps, and then the rest of it there is some of the sensor data. So the BME, it's 23 degrees Celsius in this room. It's 994 kilopascals. What else is of interest in there? Correct. Yeah, it's transmitting like every 40 seconds instead of like every 5 seconds, which would annoy people on APRS. It also doesn't do the CW call sign as well, which you don't want. And it uses the balloon icon here. I don't think the map is going to work because I'm not connected to the internet here with my network. But this software will basically look up the latitude and longitude, and it will map it for you, which is nice. But yeah, the map is not working there. Okay, so that's working. So now I'm going to try the part of this that's never been done before. So right now my HT is on 434.9 megahertz, which is where we're receiving. I'm going to change it to 435 megahertz. This is where it's listening. And after it sends a packet, it's going to listen. I'm going to transmit, and we'll see if it changes modes. We'll see this LED, this green LED will blink. So let's see. Transmit. Oh, I didn't see it blink, but it turned off, didn't it? Did it blink? Okay, excellent. Thank you for catching that. Okay. So, all right, nice clean spectrum there from the Baofeng, as expected. So, okay, so it's actually changing modes now, and it's going to reboot, and now it's going to switch to mode 2. Normally we change modes by using the push button, right? Which is not that effective when you're in space, right? You don't really want to have to send somebody out there to push a button. So doing it by radio is obviously how real satellites do it. So now I'm going to switch to Fox Telem, and I do that just by running the script here. The other really annoying thing about SDR software is that any SDR software is guaranteed to break every other SDR software you have running. They're all just designed to interact with each other. And we actually found 5 or 6 programs that if you configure them correctly, that they don't blow each other out of the water. So that's one nice thing about this. Okay, so this is the familiar Fox Telem. And let's see if we get something here. And while we're waiting for that, I'll just show you. I'll change this back here. Oh, okay, there's the CW. Okay. Make sure this is in the right mode. Yeah, we're in FSK 1200 bits per second, so that should work for mode 2. So now it's transmitting, but it's just the carrier. It takes about a minute for it to come good. Oh, there it goes. Okay, We are locked in. We got the nice open eye here. We've got a digital signal. I do have find signal turned on, so it'll automatically find it. And now if we go here into the FSK tab here, we should see things changing. Let's see if we see things changing. Yeah, there we go. Just got a packet there. 3.88 volts, 424 milliamps of current there. That current's a bit high. I don't know why that's high. That's interesting. And you'll notice here that it says simulated telemetry is off right now. It keeps track of the ground commands. I had done one to test it yesterday. So as we do more here, we should see this. It's not safe mode. The bus is working. The camera is working, which we use for slow scan TV. It's got a Pi camera there for doing selfies. And the transmit and receive antennas are both showing as deployed. Okay, so I'm ready to change mode again. So this time I'm going to watch it, since I missed it last time. So I'm going to transmit again and watch for the blink. There we go, 3 blinks. So now it's changed into mode 3. So mode 3 is BPSK, which is basically Fox 1E emulation. Before we were emulating, like one of the FM Foxes. So I'm going to change this now to Fox 1E and start. Okay, so that should be ready. And then while we're waiting for that, I'll just show you a couple of things here. So this is the current wiki instructions for building the CubeSatSim. You can see the whiteboards. This is the original version. But if you go in here and put 1.3.2, oh, I forgot to preload it, so we won't see it. But basically, you'll see the updated instructions, which we're going to be testing. What else do we have here? So this is the new bill of materials. And it's been simplified. Also, we're using something called Octopart. Anybody ever used them before? Yeah, it's really nice. Octopart has links to the distributors. So you put in a part, and it will tell you who has it in stock and what their price is. And when you make a whole list, oh, here we go. Oh, I'm on the wrong one here. There we go. So we're waking up in BPSK mode here. Start with a carrier. And in Octopart, you can just say buy, and it'll basically generate a shopping cart at DigiKey or whoever your preferred distributor is, which is nice. There we go. That's the beautiful sound of BPSK when you listen to it in FM, which you shouldn't, of course. But there it is. We also have a nice open eye diagram there, a good phaser. And if we go into BPSK, that gets annoying fast. We should see the data updating there as well. All right, so I'm going to change to one more mode here, because I think I still have a couple minutes, right? Still have time? Okay, good. All right, so I'm going to change back here and transmit again. There we go. So now we'll be in mode 4 in a minute. So we'll get going with that. And so I showed you the bill of materials. So this is the at the AMSAT store if you want to buy the blank boards. That's where we have them there. Did I find the AMSAT UK? I think I did not. Oh, there it is. Yeah, this is the AMSAT UK page that has the where you can order them. They just did them in green. I guess they're cheapskates. You have to pay like $5 extra to get different colors. So they just went with green. And instead of $35, it's 35 pounds too, so inflation. Okay, so now we're going to be doing slow scan TV. So I'm going to switch to QSSTV. And this is going to come up and ask me what frequency I want to listen to, because it's got a script with RTL FM. And for instance, you could pick the ISS frequency, and with an outdoor antenna, you could receive the slow scan TV images that they're sending out, which is fun. You can also choose other frequencies or do a test. So I'm going to choose the CubeSatSim. and then that will get going. And QSSTV, it does automatic, based on the tones, it'll automatically switch modes. We use Scotty 2 mode for SSTV. The only reason we use that is that there's a very nice open source stack for it that works really well. I'm sure there are other better modes, but it works. We'd like to use like the PD 180 that the ISS uses. 120, PD 120, yeah. Unfortunately, there isn't a good open source stack for that. But if you know of one, let me know, because I'd like to switch to that same one. But okay, so hopefully this is going to come up in a minute here. Actually, it's not coming up right now. That's not a good sign. We'll see. Yeah, so the old software, we just had to restart the application.
Alan, could you repeat the question for those who are online, please?
Oh, sure. The question is, why does it take so long to change modes? So right now, it could be because it's suffering an anomaly. Oh, no. Okay, it just took a while there. But now, because we have different modes, I'm actually doing PWM modulation on the Raspberry Pi Zero. And we're doing RPi TX. Remember I talked about software that kills each other? You know, these things don't interact well. So the only way to get reliability is to actually reboot the Pi each time. So before, we could just restart the software when we changed modes. So now it adds about another 20, 25 seconds. It's unfortunate. There might be a workaround in the future, but I have not found it yet. You know, these software packages, they just interact badly with each other. So. Okay, so still nothing here. I think we're having an anomaly here. Well, anyway, this proves it's a real demo here. We'll see if it comes good. Maybe it's going to wake up here. No, because I'm listening on my radio too, so it's silent. Yeah, this is what you don't want when you're CubeSat. You're listening. You got nothing. Got no telemetry, you've got no lights on it. Actually, you know what? We could send the reboot command. We could deploy the astronaut here and say, oops, let's do a hard reset. Who knows? Maybe that'll work. Okay, I'm going to go back here because I want to leave time for questions here. So if you're interested in this, if this sounds like something you're interested in, how can you get involved? Well, there's a bunch of things you can do. Certainly, you can build one if you want to. It's a fun project, and it's also fun to build. You can build it in a group. You can basically divide the boards. You know, and some people work on software, some people work on hardware, some people work on ground station. So you can do it with a group, and it's about $300 in parts for everything, which is not too bad. I think Jerry spends a little more for each CubeSat that we build. But anyway, 300 is not bad. And hopefully next year we'll have solderless kits. But the other thing you can do is you can borrow a loaner. So we have them as, basically they come in one of these padded containers, and you get the CubeSat simulator, you get a ground station, and instructions. And you know, I can ship it out to you a week before your event, and then you can get up here and be like me and do failed demonstrations with it. Mostly it works. This is beta hardware.
Hang on just a second.
Yeah.
Just a point of, sorry, Luke. Let me get a microphone to you here.
What grade level would you suggest to start with bringing this thing in?
So, I mean, building them, you know, soldering, I guess some people solder with elementary school kids. It's possible. But probably high school kids for soldering. For really getting into the details of what telemetry is and, you know, things like that, it's high school kids. But even grade school kids, you can do fun listening exercises where you just listen to the different modes and hear how they sound and talk about how, you know, the sound, decodes in different ways and the like. So you can definitely do things with it. The ARIS actually has a program, Sparky, right, is their program, and they actually have radio exercises that go all the way down to elementary, and they start off by teaching, you know, what are waves and you know, things like that, starting with the real basics, which is what you really need to go with go with younger students. And we also intend to develop some materials in the future when we're not building beta hardware like we've been for the past year and a half. Yeah.
So when you flew this on high altitude balloon,
Yeah.
How did you track it?
Yeah. So so what you can do is the Pico's got a number of serial ports. So you add a GPS module that's just got a serial interface. The software is all there, and that way when you transmit your APRS, right now this will just transmit a fixed latitude and longitude. But if you put a GPS module on there, but we didn't rely on it. We had two other trackers. One was actually a radio sonde, which right now is our favorite one. If you repurpose National Weather Service radio sondes, flash them with software so they transmit on amateur radio frequencies. There's an article in the AMSAT journal from last year by, I was one of the co-authors, but it's mainly a group in San Diego at the Mount Carmel Amateur Radio Club there. And radio sondes are fantastic for balloon tracking. We also have a commercial GPS, like a spot track as well. So, you know, on the other hand, if you don't care about recovering your payload, it's not as critical, but we like to get them back. So,
How difficult would it be to add a GPS receiver to perhaps a subsequent iteration of this CubeSatSim?
yeah, I mean, literally, it's just a matter of connecting it. The only issue is that a lot of GPS modules don't work above a certain altitude, so there's no perfect one out there. You know, you could buy like expensive ones, I guess, that would go up high, or you could buy cheap ones that are going to top out at 18,000 feet or whatever they are. So yeah, it's definitely an option for adding it in the future. Yep.
There is actually a good answer in GPS space these days, the U-Blox Max M10S.
Okay.
We're using that for high power model rocketry, and it has an avionics mode you can put it in where it doesn't max out until 80,000 feet.
80,000 feet, that's pretty
And they're
good.
about, in quantity one, they're less than $15.
They're $15 in quantity. Oh, quantity of one. Excellent. Okay. And so that was the U-Blox M10S. Okay, I think we're recording, so we're good. Okay, so I'm at the questions point here. You can always email me. And there's also a good, if you go to the wiki page, go to the GitHub page, there's an active discussion forum there.
Yeah, Alan, are the new boards available now, or is that coming out still in the future?
Yeah, so what I plan to do is to do an official beta release, basically. And I was hoping to have it done here, but there was a fabrication error in the latest batch. So probably in the next 2 weeks or so, I'll basically officially release it. And all the Gerbers are there, so anybody could get them printed if they want to. I'm going to get some made. We're actually planning to, if anybody has bought the blank boards from AMSAT, from the AMSAT store in the past, we're actually offering for a limited time, and I think the first 50 or so people that respond, we'll actually ship you a free blank board, basically. And with that, you could build this upgraded STEM payload board and then plug that in top. You could also get the other two boards as well, and then build your own. But anyway, hopefully in the next 2 weeks it'll be an official beta release, and I'll keep it in beta until early next year, just to get plenty of feedback, and then after that release it hopefully as the new version 2. And we're going to keep supporting the original boards, of course, and the software is backwards compatible. If you upgrade to the new software, but you have the old hardware, you just won't get many of the features. Yeah, Paul.
Yeah, I just wanted to mention to the people here that once we get this done, we're looking at a fair amount of, I guess, customer support. We're going to try and have significant information on the AMSAT bulletin board, on the AMSAT website, and we're going to develop curriculums for people to have this. Somebody asked who's going to use it, and I'm hoping that we get like high school teachers and even science teachers. And a big challenge is a lot of these people don't know much about science, don't know much about rocketry or science. So we're planning to back it up, you know, with some type of help.
Yeah, hopefully once we've literally spent 18 months developing new hardware and software. It's been a rough period. After that, we plan to switch back to developing materials, videos, exercises, things like that. So hopefully that's what I'll be talking about this time next year, not, oh, here's the latest beta that's going to be released in 2 weeks, probably.
Hey, Alan, not a question, just a comment. Virginia is watching the live stream. She wishes she was here. She was here, and she's loving the new CubeSatSim design and plans to build one.
Excellent. I'll see her next time.
I'll make a comment also. The little tag you have that says "pull before flight." I was at an IEEE meeting at University of Texas at Dallas, and there's like a Top Gun kind of a pilot that's a test pilot at General Dynamics. His son was there, and he was telling war stories about those little flags were actually used on bombs on planes, and the pilot's supposed to walk around and pull those pins before he takes off. And he was in formation, and one of his buddies didn't pull the pins, and he could see the flags over there flashing. So those are real things.
There's a reason why they're red.
That's right.
Yeah, and I think AMSAT has a sad story about them too, which goes way back.
5 minutes.
All right. So yeah, I'll just close by acknowledging this work is built on the work of a lot of others, including Mark Spencer, WA8 SME. He built the first CubeSat simulator many years ago. And also it owes a lot to Bob Bruniga's LabSat work as well, and also the simplicity. He was very good at designing very simple, very low-cost hardware, and that's something that we've tried to emulate here with the CubeSat simulator. And finally, just want to thank all the members of AMSAT, the board of directors, everybody who's supported our work over the years. And any other final questions? Okay, well, thank you.
Thank you very much. All right, that was Dr. Alan Johnston, and excellent demo, Alan. Thank you very much for doing that today.